Time break. Just as you're learning delta epsilon proofs, you go on a break. We should have just skipped it and kept going. All right.
Yes.
All right. How about 103, number 9? Would you like to walk through the delta epsilon proof for 103, number 9?
Yes.
Okie dokie then. All right. Here we go. 103, number 9. You're to prove the limit as x goes to 4, the root of x is 2. The idea, if you like, you could break it into, I really think of this in 3 pieces. The first is, maybe even 2 pieces. Find the delta you need by going from f minus L is less than epsilon backwards to x minus, in this case, 4 is less than something. Okay? Now, when you do that, you will get x minus 4 is less than something x-ish. You will then make this is delta, but you need to make this delta epsilon and number only, no x. And you'll do that by assuming x is close to 4. We'll talk about that. Once you have your delta, when you have your delta, you run your proof. Okay. I will say this one more time. When I say run your proof, you're trying to prove the definition of a limit has been satisfied. The definition of a limit is the limit as x goes to some number is L only if there exists a delta such that if x minus c is within that delta, then it must follow that the y values will be within epsilon. That is the definition of a limit. You do not have to write all that down. I'm just trying. It's hard to prove something if you don't know what you're trying to prove. You're trying to satisfy the definition. Okay? Now, we start by finding our delta here. I'm going to work back from f minus L towards x minus, or f minus, I guess 2 is the limit here, to x minus 4 is less than something. Are you with me? Mm-hmm. Okay. So if I start at f minus L, f is the function, it's square root of x. The limit, L is the limit, it's 2. That difference needs to be less than epsilon. Julio? All right. How do we get this to x minus 4? How do I go from there to there? How do I change this? Yeah, normally we divide or factor, but here we're going to multiply. I'm going to multiply. Now this is all for your notes. This is scratch work over here. I'm not even showing this in the problem set. This is like on a sticky note or scratch paper. My proof will make all this clear, but this is for my benefit only. I'll take as much liberty and skip as many steps as I want. So if I multiply by root x plus 2 on both sides, then cool, I would get my x minus 4, which is the goal. And I'm getting there. Now, when I say find the delta you'll need, when you get there, you're going to actually find that this side is not as clean as I need it to be. It's more of a function of epsilon and x, and it's supposed to be just a function of epsilon only. Are you with me? All right. So the next step then is to figure out, well, what is x or root x plus 2 like? What number could I put in for that? Let's start by assuming that because x is supposed to be approaching 4, let's assume that x is close to 4. Now that's arbitrary, I suppose, but I'm going to say, and it's pretty common that you say it's within one number on either side of 4. So let's assume that x is close between 3 and 5. Track it? Please jump in and say, I don't get this. If I lose you, please ask. This is complicated. Now, I want to build up to, what about this root x plus 2? Well, if I square root, is the inequality maintained? If A is less than B is less than C, then is root A less than root B less than root C? Yeah, it is. And so I can throw that in. And I am breaking no rules of math. And furthermore, if I add 2 to each part, would the inequality still hold? The answer is yes. All right? Once you get to that stage, you are staring your delta in the face. Delta is always the lesser. Notice I didn't say the leftmost. It's the lesser of the inequality. That delta, the reason I don't want to say it's the leftmost is because if I take fractions and this switches along the way, then the leftmost might be on this side, or the lesser might be on this side. So you choose the lesser. So I am going to go with the delta of root 3 plus 2, and at some point then I'm going to need that epsilon. You with me? Are you with me? Okay. Now all that was just scratch work off to the side. If you could do that in less steps, go for it. But the proof needs to be thorough and step by step. Are you ready to prove? Are you ready to prove?
Yes.
Are you still ready? Okay. Now remember what you're trying to show. You're trying to show that this can be shown to be true. The limit is L if there exists a delta such that when this happens, that must happen as a consequence. I am saying there is such a delta. Let delta equal root 3 plus 2 epsilon. When that happens, I will show that if x is within that delta of 4, then it must follow that the function will be within epsilon of the limit 2. I kind of stated what I'm about to show. For the person reading this, I'll show this must happen. And therefore, I'm satisfying the definition. Are you ready?
Yeah.
All right. Now, when you prove an if-then statement, you assume the antecedent or the hypothesis, and you show the conclusion follows. So I'm going to assume that if x minus 4 is less than delta is assumed, then it must first be the case that x minus 4 is less than root 3 plus 2 epsilon. Because I just said that epsilon let delta equal root 3 plus 2 epsilon. You with me? Are you with me? Mm-hmm. All right. Now put yourself in the shoes of the reader, or in other words, me. I don't see all this stuff. I see now you just went from delta to root 3 plus delta epsilon. At that point, I'm thinking, what's that? Where's that coming from? Where are you getting that? So now you need to make clear where that comes from. That's where you do this stuff for the reader. Hi. Thanks. Okay? So we're going to clearly show where that's coming from.
Wait,
Go ahead.
do you need that first if-then statement? Like, what is that? Like, I get the second part.
This part,
Yeah, what is that?
or this is what you're trying to prove. That's basically showing the reader, hey, I'm going to satisfy the definition of a limit.
Okay, and then how'd you get from x minus 4 is less than delta to the f of x?
This, I defined delta as that. And so I just replaced delta with that.
Okay.
Okay? Okay. Now, this is where we're at. I'm going to show you, hey, this is where that's coming from. Because right now it feels like that's just crazy out of nowhere. All right? This is kind of now off to the side showing where this is coming from. I'm going to come back and finish taking this towards eventually building towards f of x minus 2, right? My goal to prove is to take this and show as a consequence it must be the case that f minus 2 is less than epsilon, right? Are you with me? Do you have any idea what I'm trying to do here? Mm-hmm. Okay. All right, so I'm trying to get from this to f minus 2. First, though, I have to explain where this is coming from, and that's what's going to free me up to get the rest of this proof moving, all right? So we got this by first assuming that x is close to 4. Now, if x is close to 4, then after that, we are trying to get in the square root of x, and we said it must be the case that that's true. Yeah. Furthermore, if I add 2, that must be true. You tracking? Now here's where I go into a little more detail. I need to, actually, yeah, that's all right, I'll put it in there. All right, last but not least, I need the epsilon in there. So I'm going to multiply through by epsilon. Now I don't have to sweat, do I switch the inequality or not, because epsilon must be a positive quantity. So if you're thinking, but what about the inequalities? If I multiply through by that, do I need to switch them? Which I'm sure you were considering it. You don't have to worry about that because epsilon is defined as positive. You look up at the top, f minus L can be less than epsilon if epsilon is negative. All right, so far so good. Are you with me here, people? All right then. Now here's where I would come back and make the connection to what this is talking about here. You could do this in a trichotomy, which is the original way I taught this, but I explained this to somebody in 7th hour, and I said it a little differently, and it stuck a little better. So let me say this a slightly different way. Now, if I look at this, if x minus 4 is less than root 3 plus 2 epsilon, and over here, epsilon, or root 3 plus 2 epsilon, root 3 plus 2 epsilon is less than epsilon times root x plus 2, then it must be the case that if x minus 4 is less than that thing, and that thing's less than epsilon root x plus 2, it must be that x minus 4 is less than epsilon times root x plus 2. Yeah. Yeah. Now you could, I wrote that in a trichotomy kind of way before, where I said this all at once. So I think when I taught this first, I said, if x minus 4 is less than epsilon root 3 plus 2, and that's less than epsilon root x plus 2, then it must follow that x minus 4 is less than epsilon over root x plus 2. If that makes more sense to you, then do that. It's the same logic. Are you with me? All right then. Now I'm trying to finish the proof by showing that this is supposed to eventually be the outcome. So how do I get from where I'm at now to f minus 2 over here? Look back here. If I want to, you could either factor this or divide this over, but either way it's fine. Do you agree that x minus 4 is root x plus 2 root x minus 2? Okay. Oops. So if I divide root x plus 2 over, then I get root x minus 2. Oops, that's like that. Parentheses. And isn't that f of x in itself? No, this is where I was trying to put you. Now, your class was a little more quiet. I had a definite feel for how they were doing the last class, but you're kind of quiet, so I'm not sure if you have to clue or if you're just not happy. Shall we walk through one more together where you do a little more of the talking or no?
Yes.
Yes.
All right. When I say you do a little more of the talking, it really should be you more talking because you could write down what I write down all day long. It does not mean jack nothing about you understand. Okay? I could get a 5-year-old to write what I'm writing before. No doubt about it. But questions do understand. And you're only going to get it by asking. Yes. Oh, sorry. Go. Please do. I promise you, when this starts to click and it's all logical, then you're going to take a huge step forward as a higher math kind of person because you're stepping into the higher math world where it's not just me solving this problem by using this algorithm that they taught me and I regurgitated, but actually using logic to prove something that hasn't been proven. All right. Ty, we good?
Yeah, we're good.
Okay, cool. So is there another one of this homework that we could tackle? 103, was there? Where is 103? Thought there was one more. Yes. 103 number, I guess, 13, sort of? 12 and a half. Yeah, that sounds good. Okay. All right. Prove. This one's actually easier than the other one, I think. Prove the limit of x goes to 2. Of x squared plus 1, which is 5. If you did this on your own, the first thing you would want to check is your delta. Actually I'll say it over here. My delta, check your delta. My delta was epsilon over 5. How'd you do?
Good.
Good. You got that? Excellent. Okay. Should we just start with the proof then? Or do we need to go back over where that came from? Okay. Well, let's just go with the proof then. I will show that if x minus 2 is less than that delta, then it must follow that f of x minus... Yes? Sure. And actually, yeah, you'll probably see it in the proof itself, but all right, I'll do the find the delta, and then you can do the proof. All right. So the idea then is you go from f minus L back towards x minus 2, and this is your delta. Okay. So let's start here. F minus L. Oops. X squared plus 1 minus 5 is less than epsilon. All right. Now what do I do? Simplify. So x squared minus 4 less than epsilon. What am I trying to do now? Where am I trying to go? Trying to get x minus 2. So to get there, you could divide out what? X plus 2. Okay. Now, you need a more numerical kind of value. How do you get that numerical delta, not epsilon x delta? Yeah, you let x go between 1 and 3. And then you build out towards what x plus, that should be a 2, shouldn't it? No, when you take the fraction. So in terms of what's going to happen when you take the fraction, first of all, I'm going to put a 2 in there. If I add 2, then I get this, yeah? I think you'll agree that anytime you make an inequality that's true, and you take fractions or take reciprocals, the inequalities must switch in order for it to remain true. If you take reciprocals, every inequality changes to the other way. Otherwise, if you kept them the same, that obviously is total nonsense, right? Think of it like dividing over everywhere. So when you do that, then when I make the inequalities, it becomes 1/3 is greater than 1 over x plus 2 is greater than 1 over 5. I can throw in the epsilons. I can throw in the absolute value. All that is for my benefit only because it's not even the proof. I'm just kind of doing some scratch work off to the side. But as I said, your delta is always the lesser. Let delta equal epsilon over 5. Not the leftmost, the lesser. So now you're ready to let your proof roll. Your proof, or your thesis for the proof, is if you're saying there does exist a delta. That delta is epsilon over 5. And when that x minus 2 is less than that delta, it can be shown, or it will follow, that f of x minus 5 is less than epsilon. You ready? Okay, so if x minus 2 is less than delta, then x minus 2 must be less than epsilon over 5, by my definition of delta. I said delta is epsilon over 5. This is where we then go off to the side, because at that point the person is saying, what? Epsilon over 5? Where is that coming from? Why 5? That's where you say, well, looky here. If I assume x is close to 2, then x plus 2 must be between 3 and 5. Let's be clear. You need to go slowly. So I need to get the epsilon in. I need the fraction in. I need the absolute value. The order of those is up to you. Can I throw absolute value on this? Does that break math? Or why doesn't it break math? What do you know about this? Positive or negative?
Positive.
It's positive. Is the absolute value of positive the same thing as the number? Yeah, so it does absolutely nothing. I think you'll agree that the absolute value of any positive number is the number. So I can throw absolute value in positive all day long. No problem. Okay, so that is 100% true 100% of the time. What else do I need to get in there to get to my epsilon over 5? I need epsilon. So can I multiply through by epsilon? Sure, it's a positive quantity, so I can definitely bring that in every place, as long as I multiply each. And then what else do I have to do? Flip. And when I flip, by rules of math, accepted rules of math, I might add. Oops. Maybe I should have done that in... My bad. I don't want the epsilon in the denominator, do I? So I probably should have held off on that step. My bad. Let's go with the reciprocal step and then the epsilon, shall we? Say it again. Yes. Generally, my rubric reads something like -1 for every time they do two things in one. -1, -1, -1, -1. Epsilon over 3. Now, I don't subtract 1 from your homework if it's only worth 1 point, and so if you skip 2 steps or combine 2 steps in your homework, I wouldn't touch it. But on a test, better believe it. So, here's where I put these two things together. I know x minus 2 must be less than epsilon over 5. I also know that epsilon over 5 must be less than epsilon over x plus 2. And so, if x minus 2 is less than epsilon over 5, which is less than epsilon over x plus 3, plus 2, excuse me, then removing the middle, x minus 2 must be less than epsilon over x plus 2. If I then multiply x plus 2 over, I don't worry about the inequality because I just had an absolute value on that. That's positive. Can I put those two together in one absolute value? Sure. Okay. And then what's the last thing I need to do? Remember where I'm trying to get to. I'm trying to get to f of x minus 5. What's f of x? Square plus 1 minus 5. So what do I need to do now? I need to break up -4 into and that is f of x minus the limit. Or that is what I was trying to prove. Hi. Oh. All right. So, there you go. How about other questions on 103?
1, 2, and 3.
1, 2, and 3. Super. Can I hear another one? 7. Alrighty then. 1 is a bit of a humdinger because you can't have partial trees apparently. That makes the problem considerably more work. I think I can clean it up and give you a little less than I did in my homework. You can streamline a little bit and we'll think that through. So, the part that I would expect you to be able to do at this point, is you should be able to do a straight up optimization problem of finding the best price or maximizing revenue. If you still are having trouble with getting the equation down to two variables, then you best come in and practice that, because we're not going to practice too much more, and I will expect you to notice. They say that when the price is 20, he sells 25 trees. That's an end. And when he drops the price by $1.50, he sells 7 more trees. So, for example, one case would be if I sold them for $18.50, he would sell 32 trees. That is a linear relationship. You should be able to write the NP equation. You have 2 points. There is zero reason why you shouldn't be able to write that equation anymore. Any Algebra 1 kid should be able to write an equation between 2 points of a line. Okay? So, you should, after finding that equation, find that the relationship was something like, n is negative 14 thirds p plus 355 over 3. Okay, now with that, you have the equation down to 2 variables. You can start to maximize revenue. I distributed. And then I took the derivative. So I got something like negative 28 thirds p plus 355 thirds, and I want to know where this is 0 or undefined. P then is 355 thirds times 3/28, or the best price is 355/28. You with me so far?
Yeah.
Okay. Now here's where the problem is. 355/28 is $12.67. 12.678, so 12.68. Now the problem is, they ask, what should the price be and how many trees? That is not a whole number of trees.
As a 12.
Oops, sorry. I rounded badly. That's really some crazy round. Okay, this is not okay because it's a partial number of trees. So we need to figure out the closest clean case nearby. Okay, so in terms of where the price and the numbers sold were, we know that $20 sold 25. And when we drop it by $1.50, we would get 7 more sales. So if you go by multiples of $1.50 down, you'll get something like 17, 15.50, 14, 12.50, and then 11.25, obviously, or 11 after that. This case is the one that's closest to the price that we found. And so we're going to go with that case. When I set the price of $12.50, I get something like 46, 53, 60 trees. You follow? Okay. How about 2? Is 2 still a question? Is that the southwest driving thingy? Cool. A car, here's an intersection. A car going this way is going 30 miles an hour, 40 miles an hour, 40 miles an hour. You follow? And they say the car going south passes through the intersection 30 minutes later. That stinks. And it's going 50 miles per hour. They want the rate at which the distance, how fast the distance between the two is changing. Find dt 1 hour after the southbound goes through the intersection. You follow? Okay. What did you call your variables? I think you'll agree that these distances are variables. So what did you call them? X and Y? Let's go with X and Y. What is that 40 miles per hour then in calculus terms? Yeah, this is dx dt. I've made a mess of this. This is x, and so dx dt, technically I guess it's negative 40 miles per hour, but I don't think it's going to matter. This is the rare time when we use the old physics. It depends on how you define your axis, blah, 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 blah. But technically it is negative because it's moving left or west. If this is y, then this is giving me dy dt, yay? Okay. Or
So
negative.
that would be negative 50.
That should be negative 50 actually because it's moving down. Do you want to go with the negatives and do everything by the book? Let's go negative. Yeah. The squares will not will matter. Actually, or the x's and y's will be negative. So it'll be a wash. It's up to you. Do you use the negatives or no?
No.
All right, no negatives it is. Boom. Okie dokie. So here we go. What's the relationship betwixt the variables?
D squared.
D squared equals x squared plus y squared. Now you might be asking, what about that whole time thing? What about that it's moving through the intersection, blah, blah, blah. It'll pan out. It'll come in. Don't you worry. It'll be there. We'll get there eventually. Okay? We want to differentiate with respect to time. So if you take the derivative with respect to time, it is 2d, dt equals 2x dx dt plus 2y dy dt. You can either sub and solve or solve and sub, whichever you prefer, but let's find our values that we're going to be plugging in. At the instant they talk about 1 hour later, so on. This car going south is going 50 miles per hour. We're taking a picture 1 hour later. How far does it go? I'll say that again because that was an Algebra 1 question. Actually, pre-algebra. 50 miles per hour for 1 hour. 50 miles. Okay. The harder one is the x. It goes 40 miles per hour, but how long has it been traveling? An hour and a half. So how far is it? 60. We also need the d. By Pythagorean theorem, this would be something like the square root of 5,100, or did I do that wrong? Is that what you said? 6,100? 36, you're right, 36 plus 25 is 6,100. So 10 root 61. Check. Now you're ready to throw everything in here. There's d dt, which is what you wanted. You could divide out at 2, which is cool, and just roll x dx dt, y dy dt, all over d million. Cool? Okay, that was 2. 3. Is 3 still a question?
Yes.
Okay. 3 says, find the equation of the tangent line at 2, y equal 2 to the x on 0 to 3 at the point guaranteed by the mean value theorem. Okie dokie. A picture might help to illustrate the idea. Here's 2 to the x. Like that, yay? When they say the point guaranteed by the mean value theorem, does that mean integrals or derivatives? Is it the average value, or are they talking where the average rate of change equals the instantaneous rate of change? What are they talking about? Yeah. When they say MVT, that means find the place where the average rate of change equals the instantaneous rate of change. There's the average rate of change on the interval. Where's the instantaneous rate of change the same? There must be a place by mean value theorem where the instantaneous slope is the same, or the tangent slope's equal to the secant slope. Gotta be. So we first need to find that point. Then we're going to find the tangent line at that point. We're going to find that tangent equation. Cool. All right then, let's find the point first of all. By mean value theorem, and I did check to see that it is differentiable and continuous. F prime at C must equal F at 3 minus F at 0 over 3 minus 0. Let's get into the details. What's F prime at C? What's the derivative of y equals 2 to the x at 2 to the x log 2. So this is 2 to the c log 2. F at 3 is? F at 0 is? 3. Okay. So 2 to the c is 7 over 3 natural logs of 2, and c must be, how do I get rid of 2 to the power? Log. Log base 2 of 7 over 3 natural log of 2. All right, great. It says find the tangent line at the point. Well, I found the point, or at least I found the x of the point. Now I'm ready to do my tangent line, yeah? What's the point? The question I'm sure you've asked yourself many times. What's the point? What's the x? Log base 2 over 7 of 3 over 7 over 3 natural log of 2. What's the y? Yeah, 2 to that x would just be 2 to the log base 2, which is just the thing. Yeah? 7 over 3 natural log of 2. Cool. The slope is even easier. What's the slope? This big thing. Isn't the slope the derivative? And the slope is, is it? Yeah, it's 7/3. I made a mistake in the last class. The slope at that point is 7/3. Sweet. And so your tangent line equation is y minus 7 over 3 natural log of 2 equals 7/3 x minus log base 2 of 7 over 3 natural log of 2. Boom. Okay. 7. Question on 7. Is 7 still a question? Yes. Okay. On 7, you shouldn't have to do background work for your delta. What is delta for lines? Delta is always epsilon over the absolute value of the slope. So delta equals epsilon. Okay, so what then did you do? Now you're proving. You're ready to prove. If delta equals epsilon, if you let delta equal epsilon, then if x minus 4 is less than that delta, then it must follow that f of x minus 1 is less than epsilon. That should be good. If you can't do that, you should probably get into some kind because that's as easy as it can get. Linear with a total 1. All right. Questions on 104? 4 or 103? Whatever you got left. They're both due today, regardless.
3.
30?
3.
3. I was going to say 30. Doesn't make sense. 104, 3. All righty. Shoo-be-doo. I imagine a lot of people missed 2 in the last class, 104, 2. Maybe you talked about that instead. 2, your answer might have been exactly half of what it should have been.
Yeah.
And that's because it's coded on both sides, not just one
So
side.
did you get 1.2%?
Yes, 1.2% and 0.012 for the relative rate. Yes?
Yeah.
Okay. So 3, they give you that the cost function, or cost as a function of number produced, is x times x minus 150 squared plus 140. Okay? So use differentials to estimate the cost of producing one more item than that 151. So it says cost of producing one more item, so I really want to know what's the change in the cost. What's the change in cost? When I change x by 1, how much will cost change by? Now, delta C can be approximated by DC. Yeah? What's DC equal to? The derivative, I heard?
Yeah.
C prime times dx. Perfect. Okay, now you're rolling. What's the derivative? By product rule, I suppose we could use. First stays the same. Derivative of the second plus second stays the same. Derivative of the first. All right. At what value do we evaluate that? At an initial value of 151. And how much are we changing that by? Or how much more are we producing? We're trying to estimate the cost of producing 1 more. I want to change the number produced by 1. They want to change how much they can produce 1 more, which means x, the number is going to increase by 1. Does that get you going?
Yeah.
Okay. Other questions on 104? For if you're checking your delta epsilon, 104 number 20, my delta was 2 epsilon. How'd that go? Is that what you have? And is your improved flow or not so much?
I just said delta equals epsilon.
You what?
I just said delta equals epsilon.
I do not believe that works. I'll have to look at your proof, but I do not believe you can make that happen. If you start at f minus L less than epsilon, then doesn't that mean 1 over x, 2 over x minus 1 over 2 is less than epsilon? Yeah? Do you agree? Isn't the function... Oh, no, it's 1 over x. Why did I do 2 over x? Oh, I don't know. Sorry, 1 over x. Yeah? Do you agree?
Yeah.
Common denominator would be 2 minus x over 2x. So 2 minus x by itself would be less than epsilon times 2x.
Okay.
Right? And if x is between 1 and... what is it between 1 and 3? Then 2x is between 2 and 6. And so there's your 2 epsilon is your delta.
Yeah.
Right. And then prove the length. All right, I'll probably throw a quick status check homework quiz at you sometime this week to see if you have a clue what's going on at a basic level. Have you been doing the homework?
Daniel Pacheco, please come to attendance. Daniel Pacheco, please come to attendance.
You're going to start with P, so you have it. Yeah, I'm all for not doing it twice.
No, like you can't start like this.
It's better voice.
Well, I haven't,
All senior ed course, finish your course.
like just so it makes more sense. I'm not doing that. Like,
It would be like starting a third paragraph of this. All right, now I'm going to write what it says.
Actually, that's a good thing.
Start with the third paragraph.
no, not the
and
third
write down.
paragraph, but you get the introduction.
Actually, on the term paper would be good because you had a two-paragraph introduction.
When you go to write it,
You write the body first.
It makes more sense.
and you put it in the actual you.
No, not
So
order.
that's what that's-
So when you write it,
Oh,
That makes, I like how you do that, like it makes, hey, Mr. Rickman.
yep.
So I did this and I think I did it right, but then, you know, I don't see why not.
Just a second, I didn't walk away from you for no reason, I just have
You
to.
need to find a new place to go. Please do that right away.